Welcome to Quality Insulation Installation, a WISE educational program brought to you by Console. This course is a WISE educational program brought to you by the California Energy Commission's EPIC program. Insulation only works if it is installed correctly. For many years, insulation was poorly installed, leading to higher than necessary utility bills. Quality Insulation Installation, or QII, is a set of procedures that guides the installing contractor through the process of creating an efficient envelope that will then be verified by a HERS rater. It involves not only installing the insulation per the manufacturer's specifications, it also requires air sealing of the cavities to achieve a true thermal barrier. QII is currently a performance option under the 2016 code, but will become a prescriptive measure once the 2019 standards go into effect. A home without QII is only able to achieve credit for 70% of the installed R value. This is a significant penalty that is difficult to overcome. QII consists of three main components: continuous air barrier, infiltration air sealing, and insulation installation. These components work together to address the two methods of heat transfer that occurs: conduction and convection. A continuous air barrier is necessary to stop air leakage through the building envelope that separates conditioned from unconditioned space. This air barrier consists of a combination of interconnected materials and assemblies that are joined and sealed together. The air barrier can be constructed out of many different materials, some of which include plywood, rigid foam, spray foam, and drywall. The air barrier should be aligned with the thermal barrier. An airtight cavity or assembly limits the passage of air into or out of the building envelope. To be considered airtight, all openings shall be caulked or sealed with minimally expansive foam or taping sealing of adjoining surfaces of air barrier materials and assemblies. Minimally expansive foam is used to seal and fill small gaps and cracks in the air barrier. While the main purpose is air sealing, it can also be used to fill spaces between framing members that are too small to insulate. Check with window and door manufacturers prior to installation, as some do not allow this practice and will void the warranty. Hardcovers are made from common building materials such as plywood or drywall. They are placed on top of chases and drop ceilings to create a uniform sealing air barrier. Any gaps, seams, or holes will need to be sealed to create an airtight barrier. Draft stops are installed to prevent the movement of air within open spaces such as crawl spaces, floors, ceilings, walls, roof assemblies, and attics. Draft stops are generally installed to meet fire code requirements and are not part of the air sealing measures. The only exception is if the draft stop is in alignment with the air barrier, in which case it will need to be made airtight. Voids in air spaces can be caused by many different things. The primary reasons are an uninsulated space created by partial filling of the framed cavity and excessive compression. The insulation should be installed in such a way that it is in contact with all six sides of the cavity: front, back, top, bottom, left, and right. Any area where the insulation is not in contact is a void or an airspace. Gaps are uninsulated areas at the edge of the insulation where the insulation is not in contact with the framing members. This is a result of insulation that is not properly sized for the cavity. For example, fiberglass batts should be 1 inch wider and 1 inch taller than the bay it is to be installed in. This allows for a friction fit without excessive compression. Compression is the result of too much insulation installed into the cavity. Insulation that is compressed loses its ability to resist conduction of heat. It also creates voids and air spaces. Delamination is the separation of the insulation's full thickness to facilitate its insulation around or between obstructions. This is the most common method used to insulate around electrical wiring. Friction fitting is a method used to install insulation into a framed cavity without the use of mechanical fasteners. Friction fitting of faced batt and blanket insulation, with or without an attachment flange, is allowed, provided the insulation's installation integrity can be maintained. Insulation should be sized 1 inch larger than the cavity it will be installed in to prevent excessive compression. Inset stapling of faced batt or blanket insulation is allowed as long as the void created is not greater than 2 inches from the stud to the contact point with the air barrier. Face stapling is the preferred method and should be used if possible. Net-free area describes the part of a vent that allows air to pass through. Mesh screens and louvers block the flow of air and are accounted for in the net-free area calculation. For example, a 22.5-inch by 3.5-inch eave vent screen with a total area of 78.75 square inches may have a net-free area of only 45 square inches. Batt and blanket insulation is made of mineral fiber or fiberglass and mineral wool. It is used to insulate below floors, above ceilings, below roofs, and within walls. Loose fill insulation consists of loose fibers or fiber pellets that are blown into building cavities or attics. It can be installed in walls, floors, attics, and below roofs using a moist spray technique or dry pack process that may include a netting material. Rigid board insulation is made from fiberglass, expanded polystyrene, extruded polystyrene, polyisocyanurate, or polyurethane. It can be used for above roof decks, exterior walls, cathedral ceilings, basement walls, and as perimeter insulation at concrete slab edges. It may also be used to insulate special framing situations such as window and door headers and around metal seismic bracing. Spray polyurethane foam insulation, or SPF, is a two-part reactive system that is mixed at a spray gun or a single-part system that cures by exposure to humidity. The liquid is sprayed through a nozzle into wall, roof, ceiling, and floor cavities. SPF can be formulated to have specific physical properties that affect its density, compressive strength, fire resistance, and R value, and will be either an open cell or closed cell structure. Structurally insulated panels, or SIPs, are a composite building material consisting of an insulating layer of rigid polymer foam sandwiched between two layers of structural board. They can be used for many different applications, such as exterior walls, roofs, floors, and foundation systems. Extra planning must be done for the routing of wiring and plumbing around or through the SIPs panels. Insulated concrete forms, or ICF, are interlocking modular units that can be dry stacked and filled with concrete. They lock together externally and have internal metal or plastic ties to hold the outer layers of insulation in place to create a concrete form for the structural walls, roof, ceilings, or floors of a building. Compliance with QII requires that the installing contractor complete the required documentation by filling out the Certificates of Installation, or CF2Rs. The CF2R ENV21 covers air infiltration sealing at the framing stage for Batt, loose fill, and SPF insulation. The CF2R ENV22 covers the air infiltration sealing of the ceiling and roof. The CF2R ENV23 covers all insulation installation. And the CF2R ENV24 covers air infiltration sealing at the framing stage for SIPs and ICF construction. The QII inspection process is separated into three stages: air sealing of the framing, air sealing of the ceiling and roof deck, and the insulation stage. As previously described in the forms section, each stage has its own form. Because the air sealing and insulation installation is done at different times, the inspection of QII will require multiple trips to the job site. The R value of all insulation will need to be verified either by the markings for batt and blanket insulation or by the thickness of loose fill and SPF insulation to ensure that it meets the values listed on the Certificate of Compliance. All insulation must be installed per the manufacturer's specifications to achieve the listed R value. For loose fill and SPF, you will need to measure the installed thickness in at least 6 random locations per surface. Surface types include the wall, roof, ceiling, and floor. For walls, measurement areas shall include low and high areas of the insulated assembly, and verified density measurements are consistent with the manufacturer's coverage chart. Labels, specification data sheets, and/or coverage charts will need to be provided for each insulating material. In addition to verifying the installed R value, there are additional verifications that must be performed for air sealing and installation quality: walls, ceiling, roof, floor. Wall stud cavities shall be caulked or foamed to provide a substantially airtight envelope to the outdoors, attic, garage, and crawl space. This includes but is not limited to all gaps around doors and windows, plumbing and wiring penetrations through the top and bottom plates, and electrical boxes that penetrate the sheathing. Bottom plates of framed and non-framed assemblies shall be sealed to the ground subfloor or slab and above ground subfloor. Top and bottom plates are sealed to the drywall. Exterior wall air barrier is sealed to the top and bottom plate in each stud bay. Rigid board insulation shall uniformly fit across the plane of the wall, and taping and/or caulking of all joints and seams of the insulation shall be maintained to be considered as the air barrier. Connections of wall panels shall be sealed, caulked, foamed, or taped to provide a substantially airtight envelope to the outdoors, attic, garage, and crawl space. Bottom connections of wall panels shall be sealed to the ground subfloor or slab and above ground subfloor. All plumbing and wiring penetrations through the top and bottom of panels and electrical boxes that penetrate the SIP sheathing shall be sealed. All top plates need to be sealed to the drywall. Connections of the ICF walls shall be grouted and sealed, meeting manufacturer's specifications. All plumbing and wiring penetrations through the top and bottom of the ICF and electrical boxes that penetrate the plane of the ICF shall be sealed. All gaps between interconnecting envelope assemblies of different materials shall have the air barrier caulked, sealed with minimally expansive foam, or taped. Bottom connections of ICFs shall be sealed to the ground subfloor or slab and above ground subfloor. Insulation shall uniformly fit across the plane of the wall, and taping, caulking, or sealing of all joints and seams of the ICF shall be maintained to be considered as the air barrier. Insulation shall be kept away from combustion appliance flues and chimneys with sheet metal flashing in accordance with flue manufacturer's installation instructions or labels on the flue. The flashing shall be sealed to the surrounding framing using fire-rated caulk or foam. Insulation shall uniformly fill the cavity, side to side, top to bottom, and front to back. Insulation shall be installed to fill the cavity and be in contact with the sheathing on the back and the wallboard on the front. No gaps or voids. Batt insulation shall fill the cavity by friction fitting, inset or face stapling of flanges of face batts, or by other support methods as necessary. Batt insulation shall be cut to butt fit around wiring and plumbing, or be delaminated so that one layer can fit behind the wiring or plumbing and one layer fit in front. Loose fill wall insulation shall be installed to fit around wiring, plumbing, and other obstructions. Non-standard width cavities shall be filled with insulation to snugly fit into the space, or with minimally expansive foam sealing material. Narrow spaces less than 1 inch in width at windows and door jambs shall be filled with minimally expansive foam sealing if allowed by manufacturer. Stuffing batt insulation is not allowed. Narrow spaces less than 2 inches in width, such as between studs at building corners and at the intersection of interior partition walls to exterior walls, shall be filled with insulation snugly fitted in the space or with minimally expansive foam sealing. Hard-to-access wall stud cavities, such as corner channels, wall intersections, and behind tub shower enclosures, shall be insulated to the proper R value. In most cases, this can only be completed prior to the installation of the tub shower enclosure, the exterior sheathing, or the exterior stucco lath. An air barrier shall be installed on the inside of the exterior walls directly adjacent to the tub shower enclosure. In cold climates, where water pipes may freeze, pipes shall have at least 2/3 of the insulation between the water pipe and the outside surface of the exterior wall. If the pipe is near the exterior finish assembly layers, as much insulation as possible shall be placed between the pipe and the outside without excessive compression, and remaining insulation shall be placed between the pipe and the interior assembly material. All band joists and rim joists shall be airtight and insulated to the same R value as the adjacent walls. Framing for knee walls, skylight shafts, and gable ends that separate conditioned from unconditioned space shall be air sealed and insulated to meet or exceed the wall R value specified on the Certificate of Compliance and all other required compliance documentation. For steel frame knee walls, skylight shafts, and gable ends, external surfaces of steel studs shall be covered with insulation unless otherwise specified on the Certificate of Compliance using correct U factors from Joint Appendix JA4, Table 4.3.4. The backside of air-permeable insulation exposed to the unconditioned attic space shall be completely covered with rigid board insulation or an air barrier. The house side of the insulation shall be in contact with the drywall or other wall finish. Insulation for all knee wall and skylight shafts shall be completely enclosed by and in full contact with sealed vertical and horizontal framing, including horizontal plates at top and bottom of the insulation. Walls of interior closets for HVAC and/or water heating equipment which require combustion air venting shall be insulated to the same R value as the exterior walls as specified in compliance documentation. Insulation shall fill the entire cavity, or an additional air barrier shall be installed inside the double wall or bump out and in contact with the insulation on all 6 sides unless SPF is used. Entire double walls and framed bump outs shall be airtight on all unconditioned sides. Installation shall be installed in a manner that restricts thermal bridging through the structural framing assembly. Insulation shall be applied to fully enclose and/or adhere to all sides and ends of structural assembly framing that separate conditioned from unconditioned space. The structural portions of assemblies shall be airtight. Window and door single-member headers shall be insulated to a minimum of R3 for a 2x4 header or equivalent width, and a minimum of R5 for all other assemblies. Insulation is to be placed between the interior face of the header and inside surface of the interior wall finish. If you are using continuous rigid board on the exterior or ICF, headers shall be insulated to a minimum of R3 between the exterior face of the header and inside surface of the finished wall material. When an electrical panel is located in an exterior insulated wall, the panel shall be airtight, and insulation shall be installed behind the panel. This can be an issue in 2x6 or larger wall cavities. Any fan exhaust ducts that run between conditioned floors to exterior walls have to include a damper at the exterior wall. From below, this ledge looks complete. Climb up above, and it is easy to see that the interior air barrier is not complete. Air is free to travel into and out of the wall cavity. Here is a good example of properly sized and installed batt installation. This installation suffers from many issues. Several batts were cut much too short and show signs of excessive compression. The batts in the center of the picture were stuffed behind the pipe in the wall. And if you look to the lower section, you can see bulges where the electrical is run, which indicates that they did not delaminate the batts around the wires. Here is an example of batts that were properly delaminated around an electrical wire. When the batts are placed back in position, you should not be able to tell that there is a wire running along that section of wall. Here is an example of a rim joist running between floors on a 2-story house. The rim joist needs to be treated the same as the exterior wall below to stop heat transfer into the space between floors. Electrical boxes are just like any other obstruction. The installer needs to cut out a section of the batt to provide space for the box. Also, don't forget to insulate behind the box. This is a good example of a wall with both plumbing and electrical obstructions. The batts have been cut to fit around the obstructions and were sized to friction fit in the bays without excessive compression. Ceilings must also be verified for air sealing and installation quality. Hardcovers, or draft stops, shall be placed at ceiling level over drop ceiling areas, interior wall cavities, and double walls to keep insulation in place and stop air movement to and from unconditioned space. If hardcovers or draft stops are missing or incomplete, they shall be completed before insulation is installed. Any penetrations cut into the ceiling are sealed to the surrounding drywall. Includes but is not limited to electrical boxes, fire alarm boxes, fire sprinklers, HVAC boots, and exhaust fan housing, including all holes and seams in the housing itself. In unvented attics, there is a continuous air barrier at the roof deck and gable ends, and all penetrations must be sealed. Insulation shall be correctly sized to fit snugly at the sides and ends. Insulation shall be installed to be in contact with the air barrier, which will be the ceiling or hard covers. Insulation shall be applied all the way to the outer edge of the wall top plate, and flush against any ventilation dams or baffles. Rigid board insulation installed above the roof deck shall be applied to the outer edge of the plane of the wall top plate. Batt and blanket insulation that is thicker than the truss depth shall be installed so that the insulation expands to touch the adjoining cavity over each truss member. Where necessary, batt and blanket insulation shall be cut to fit properly. There shall be no gaps, nor shall the insulation be doubled over or compressed. When batt and blanket insulation are cut to fit a non-standard cavity, they shall be snugly fitted to fill the cavity without compression. Batt and blanket insulation shall be cut to butt fit around wiring and plumbing, or delaminated so that one layer can fit behind the wiring or plumbing and one layer fit in front. Baffles shall be placed at all eave or soffit vents of vented attics to keep insulation from blocking eave ventilation and prevent air movement under the insulation. The required net-free ventilation area shall be maintained. Recessed light fixtures shall be rated as insulation contact and airtight, more commonly referred to as ICAT. They shall be sealed with a gasket or caulk between the light's housing and the ceiling. Insulation shall cover all recessed lighting fixtures to the same value as the ceiling. If not, an area-weighted calculation is required. Insulation shall be kept away from combustion appliance flues and chimneys with sheet metal flashing. A clearance of 1 inch for double wall flues and 6 inch for single wall must be maintained or be in accordance with the flue manufacturer's installation instructions or labels on the flue. The flashing shall be sealed to the surrounding framing with fire-rated caulk or foam. Insulation will be in full contact with the flashing and the collar must be at least as tall as the depth of the insulation. Attic rulers appropriate to the installed insulation shall be evenly distributed throughout the attic to verify depth. A minimum of 1 ruler for every 250 square feet shall be installed and be clearly readable from the attic access. Attic rulers shall be scaled to read inches of insulation and display the corresponding R value. Insulation shall be blown to a uniform thickness throughout the attic with all areas meeting or exceeding the insulation manufacturer's minimum requirements for depth and weight per square foot. Verify that, at the time of installation, the insulation depth is greater than or equal to the manufacturer's minimum initial insulation thickness. The measured weight per square foot, or density, of fiberglass insulation must be greater than the manufacturer's specifications required to achieve the target R value on the CF1R. All enclosed rafter ceilings shall maintain an airspace between the insulation and roof sheathing per the California Building Code, or as specified by the local building department. In unvented attics, where insulation is applied directly to the underside of the roof deck, or where SIPs are the insulated roof structure, all gable ends shall be insulated to the same R value as the exterior walls as specified in the compliance documentation. Insulation shall be placed below any platform or catwalk for HVAC equipment installation and access, to the same value as the ceiling insulation. Insulation shall be installed so that they will be in contact with the air barrier. If not, an area-weighted calculation can be completed for compliance. Permanently attach rigid board insulation, batt or blanket insulation with the same R value as the ceiling to the access door using adhesive or mechanical fasteners. The bottom of the attic access shall be gasketed to prevent air leakage of conditioned air to the unconditioned attic. Vertical access requires mechanical compression such as screws, latches, or doors. The attic access must be surrounded with a dam at least the same depth as the insulation to prevent loss of ceiling insulation when the access is opened. This hardcover is incomplete. The remaining gap needs to be covered and the entire assembly air sealed. This covers the entire fireplace chase and is air sealed around the perimeter. Additional air sealing around the flue, if allowed, should be completed with fire-rated caulking or foam. Here is an example of blown-in fiberglass insulation that was uniformly distributed, leaving no high or low spots. Insulation installed in the ceiling needs to be in contact with the ceiling drywall. The batts in this installation should have been delaminated or butt-fit around the plumbing and electrical. These are the steps needed to properly flash around flue vents in preparation for insulation installation. You can see here that no baffling has been installed, creating a potential fire hazard. Attic rulers that are installed should be placed on a section of the truss even with the bottom. Space them out so there is one for every 250 square feet of attic area. Rulers are most easily installed and verified if done prior to the installation of the ceiling drywall. Ceiling batt insulation needs to be sized so that voids, gaps, and compression are minimized. Floors must also be verified for air sealing and installation quality. Subfloor sheathing shall be glued or sealed to all exterior panel edges to create a continuous airtight subfloor. Batt and blanket insulation shall be correctly sized to fit snugly at the sides and ends without gaps. Insulation shall not be doubled over or compressed. Loose fill insulation shall completely fill around wiring and plumbing and be properly supported where necessary to avoid sagging, gaps, voids, and compression. Insulation shall be in contact with the air barrier, which is usually the subfloor. Hangers must be spaced at 18 inches or less and cannot compress the insulation. Netting or mesh can be used if the cavity is filled and in contact with the subfloor. If access to the crawl space or basement is from the conditioned area of the house, the access has to be airtight and insulated to the same value as the floor. Install airtight blocking in between joists where the wall rim joist would have been located in the absence of a cantilever. Exterior sheathing is installed at the bottom so that there is a continuous air and weather barrier for the cantilever. The cantilever joist must be insulated to the same R value as the subfloor prior to closing. Can lights in the cantilever shall be ICAT rated and properly sealed to the sheathing. The SIPS air barrier shall be maintained through use of SIPS tape or sealing and caulking between panels and at all spline joints. The outer and inner face and all joints of the ICF air barrier shall be maintained through the use of tape or sealing, and caulking is needed. On floors that are over garages or where there is an airspace between the insulation and the subfloor, the rim joist shall be insulated. The garage and the adjacent conditioned space, house, shall be insulated up to the subfloor. All rim and band joists adjoining conditioned space shall be airtight and insulated. The band joist, where the garage transitions to an attic above conditioned space, shall have an air barrier installed in contact with the edge of the attic insulation. In this picture, we can see that the batts are in contact with the subfloor and are properly supported to prevent sagging. Insulation shall be cut to the correct length to prevent gaps at the end or side. Craft-faced batts have been face stapled to minimize compression. When floor insulation above a garage is installed at the ceiling instead of at the subfloor, the rim joist must be insulated in order to maintain a continuous thermal barrier. Rim joists that separate conditioned from unconditioned space are to be both insulated and made airtight. Insulation that is cut too wide for the bay that it will be installed in will lead to excessive compression. If the rim joists are not insulated, then the insulation needs to be installed at the subfloor and not the ceiling. This section will discuss special considerations for SPF installation. When dealing with SPF insulation, all of the previously described installation considerations still apply, with some additional requirements. Requirements vary between closed cell SPF and open cell SPF. Closed cell SPF is not required to fill the cavities of framed assemblies if the installed thickness of installation conforms to compliance documentation, and if all framing is sprayed to completely fill the cavity adjacent to and in contact with the framing to a distance of 2 inches away from the framing for open cell SPF insulation, or filled to the thickness meeting ASTM testing as an air barrier. Open cell SPF will completely fill cavities of 2x4 framing or less, and will fill cavities greater than 2x4 framing dimensions to the thickness that meets the required R value used for compliance, provided that all framing is sprayed to completely fill the cavity adjacent to and in contact with the framing to a distance of 5.5 inches away from the framing for open cell SPF insulation, or filled to the thickness meeting ASTM testing as an air barrier. Depressions in the open cell SPF insulation surface that are not greater than 1 inch of the required thickness are allowed, provided these depressions do not exceed 10% of the surface area being insulated. When installed as an air barrier, closed cell SPF shall be a minimum of 2.0 inches in thickness, and open cell SPF shall be a minimum of 5.5 inches in thickness. Alternatively, they can be installed as a thickness that meets an air permeance of no greater than 0.02 liters per second per square meter at 75 pascals pressure differential when tested in accordance to ASTM E2178 or ASTM E283. SPF insulation shall be applied to provide an airtight envelope to the outdoors and between adjoining cavity surfaces of conditioned and unconditioned space, such as the attic, garage, and crawl space. SPF shall be spray applied to fully adhere to assembly framing of wall, floor, ceiling, the joists, and other surfaces within the construction cavity. It shall fully adhere on and around plumbing, electrical, and any obstructions within the construction cavities. When multiple layers of SPF material are applied, each foam lift shall have adhesion at substrate and foam interfaces. SPF shall be installed in conformance with the manufacturer specifications, recommendations, and temperature humidity limitations. Substrates to which SPF insulation is applied shall be secure and free of surface moisture, frost, grease, oils, dirt, dust, or other contaminants that would adversely affect adhesion. If values other than R 5.8 per inch for closed cell SPF and R 3.6 per inch for open cell SPF are used, the ICC Evaluation Service Report number will be documented on the CF2R ENV03. SPF shall not exhibit areas that have voids or gaps in the uniformity of the insulation, are extremely soft or spongy, show the presence of liquid, have blistering between lifts, show differences in coloration of adjacent foam layers, indicate the presence of other materials between lifts. SPF shall not be applied directly to recessed lighting fixtures and left exposed. Recessed light fixtures insulated with SPF insulation shall be protected from ignition by a combination of one or more of the following methods: be covered with a minimum of 1.5 inches of mineral fiber insulation, or be enclosed in a box fabricated from 1/4 inch plywood, 18 gauge metal, 3/8 inch hardboard, or gypsum board. SPF insulation shall be applied to fully adhere to the substrate of the ceiling or roof deck and to the joist and other framing faces to form a complete air seal within the construction cavity. In unvented attics, if the SPF insulation is located on the underside of the roof deck, it shall extend to the outer edge of the top plate. In unvented attics, where SPF is applied directly to the underside of the roof deck, all gable end areas shall be insulated to the same R value as the walls and as specified on compliance documentation. It is not necessary to place hard covers over drop ceilings and interior wall cavities in this situation. A minimum of 3 inches of closed cell SPF insulation or 5.3 inches of open cell SPF shall be placed below any platform or catwalk access ways installed in vented attics for HVAC equipment or other needs. The overall assembly R value shall meet the required R values specified in the compliance documentation. A minimum of 3 inches of closed cell SPF or 5.3 inches of open cell SPF insulation shall be applied to the access door, assuring good adhesion to the door surface. Alternatively, permanently attach rigid foam or batt insulation with adhesive or mechanical fastener. The overall assembly R value shall meet the required values specified in the compliance documentation. Properly installed SPF will fully fill a 2x4 cavity and may need to have portions that extend beyond the face of the studs trimmed. Improperly prepared surfaces can prevent the SPF from adhering, resulting in it pulling away and leaving gaps. Closed cell SPF does not usually need to fill the cavity to achieve the required R value or qualify as an air barrier. SPF that was not installed per the manufacturer's specifications can crack, resulting in gaps. SPF can be used to both insulate and air seal rim joists. Be sure to install the correct material to the proper thickness for both the R value and to qualify as an air barrier. Following the manufacturer's guidelines is crucial to preventing complete product failures. Now, let's discuss special considerations for multifamily buildings. Multifamily buildings must meet all air sealing requirements for single-family buildings as previously described. Each dwelling unit must be air sealed to stop air movement from one unit to another. Elevator penthouse, mechanical penthouse, stairwell doors, roof access hatches, and plumbing stacks are all sealed to reduce air transfer from attached spaces. Vertical chases for garbage chutes, elevator shafts, HVAC, ducting, and other penetration must be sealed to the floor and ceiling of each unit to stop air movement through it and to surrounding spaces. Penetrations between dwelling units and common hallways are sealed, including doors to dwelling units, which shall be gasketed or made substantially airtight. With the upcoming 2019 code change, we will see some minor changes to the QII protocols. Protocols will be added to address high-performance attics and walls. While these changes are minor, QII becoming a prescriptive requirement is a significant change. Builders will now be penalized for not complying versus getting additional credit for choosing to comply. Be prepared to have a lot of projects that need to comply with QII. The references for this training can be found in the 2016 Reference Appendices, Section RA 3.5, which can be downloaded for free from the California Energy Commission's website at the link provided. This has been Quality Insulation Installation, a WISE educational program brought to you by the California Energy Commission's EPIC program. For more information, please use the contact information on the screen, info@wisewarehouse.org.